Let me actually start my clock so that I don't run out of time in the third one. Because I know me, when I'm down to do that. My name is Chris Agocs. I work for Drama Fever, like we were just talking about. We are a company that does streaming TV using a Python and Go stack. A lot of fun, very remote friendly. You should work there if you want. But I'm not here to talk about that. I'm here to talk about key brokers. And get my fine dialogue on the screen. Here to talk about key brokers. And this is something I learned about in my last position. What we were doing was we were saving documents, like, Word documents, emails, into Amazon S3. We were indexing them in Elasticsearch. And, I started experimenting with key brokers, and I thought, well, these are really cool, really pretty powerful things. And actually, this whole talk stemmed from a problem I was having with them. I, did a lot of research. I started Stack Overflowing. I hit up the RabbitMQ IRC channel and couldn't find a whole lot of information about this fact that 0.01% of messages I was throwing on the queue weren't going on. So I wrote a blog post and then wrote a talk and then I gave it here. So let's talk about queues. Kind of go back to basics. A queue is very simply a first in, first out data structure. So you have something that produces these messages, they go onto the queue persists them until another thing grabs them off of the queue and then does whatever it needs to. So it's just this pipeline for maintaining messages. So what's a broker? Why do we care? What am I talking about? A queue broker provides these transient queues, and it makes them on the fly based on who's listening, who's saying things, what messages are being sent, and it provides a lot of dynamic flexibility as you're putting together these services. So you got the service-oriented architecture, right? And you got these services, and these services are all talking to each other. And some of them are really long-running processes, and some of them are super chatty. And you need these queue brokers to mediate traffic between these services so that, rather than tying up a thread in one place, waiting for network I/O, waiting for another service that's running on a different computer in a different data center to get back to it, you just throw the message on the queue, you trust that whatever it is, it'll get handled eventually. And that it makes building your service-oriented architecture a lot easier. So let's talk about some basics. Let's motivate an example, okay? So let's say that altogether we're building a bank, and it's a simple bank. You have your card, you swipe the card, and the bank receives this card swipe, okay? And card swipes come in, and you got to go somewhere else. You got to authorize the card swipe. You got to pull the money out of the account. So it's quick and easy, but people are going to get mad when it fails. So we got these two services, the card swipe reader and the debit processor. And we're going to throw a queue between them. So this is the card swipe reader, it reads the card swipes, throws it on the queue, debit processor processes the messages, and handles the money. So let's do an actual basic example. So I have here, this is a snippet of code from a device that generates these transactions. And this here is consuming the message, and where's my mouse? So I'm going to turn on the consumer over here. I'm going to go back here, I'm going to produce a message. Oh, look at that. All right, we got a message. I'm actually going to go down the thing. There we go. So we're producing these messages. They're getting put onto a queue that's running on my laptop, and they're getting read off by this consumer over here. So, one in, one out, super easy. Let's kill this process and make it more complicated. So, I actually skipped ahead of my note cards. There we go. All right. So let's motivate some changes, all right? Let's say, for example, that our debit service can't keep up. It takes a little bit to take the money out of the account. And that seems like a very trivial problem, but it's not trivial when you have angry people standing at cash registers with their card in their hand looking like idiots waiting for these transactions to go through. So what's the solution? We're going to add more debit processors. Just Oh, on there. All right. So each processor is grabbing transactions off the queue as fast as it can. And to add more capacity, we just add more of these type of processors so they're all grabbing these transactions off the queue and processing them as fast as they can. And we're just scaling horizontally and we're distributing load. So what are we going to do sort of under the covers? We have got a work queue that's a named queue. And each subscriber is pulling these messages off and they're doing whatever. So you get a bunch of consumers consuming. And when one consumer consumes the message, it removes the message off the queue so that these workers are sharing the load between them. Diagram, real simple. The publisher is publishing messages, putting them on the queue, and then you get, these consumers scaled like this, pulling them off. And to get better scale, you just throw more consumers on here until you're consuming messages faster than you're processing, so that your queue size tends towards 0. So let's go ahead and spin up 10 consumers. Let's create some transactions. All right, looks like worker number 9 pulled it off the queue. Worker 0 got it this time. Worker 4 got it this time. Worker 5 got it this time. Worker 1 got it this time. Worker 6 got it this time. So we're just pulling these off the queue. All right, where am I now? So I think I'm sitting there. Okay. All right, so we're just pulling these messages off the queue, one worker at a time, sharing this load. And that's going to make our process faster, more stable, just, more wonderful, more enjoyable for everybody. What's not enjoyable is fraud. But we got to deal with it, So what we got to do is we got to process the good transactions and then ignore the bad ones or find out some way to, suss out who's doing these malicious things. We bought this fantastically expensive thing called the Fraudomatic 5000. That's what does that. The Fraudomatic, it separates the good transactions from the bad. And what we're going to be doing is we're going to receive the card swipe. We're going to run it through the fraud detection process. We're going to send these successful transactions off to go get the debit, off to go get the money moved from the accounts. And we're going to send the failures off to a fraud investigation team. So the way we're going to do that is with these neat things called exchanges. And back to under the hood, an exchange is a feature offered by queue brokers. And just like you can put messages onto a named queue, you can put messages onto an exchange. And consumers bind themselves to the exchange. And the queue broker figures it uses rules to figure out what messages go to what consumers. A little more in depth. When a consumer binds itself to the right kind of exchange, it subscribes to a topic. And when messages are published, they're published using routing keys. And these routing keys tell the broker what type of content the message contains. And the topics let the queue broker know what type of messages the consumer wants. So the queue broker is dynamically creating these queues to move messages to different consumers based on what kind of message it is. And so let's go and build something. We got the Fraudomatic. The Fraudomatic reads transactions off the transaction fire hose queue, all right? And it creates the post-fraud exchange. And successes get the routing key, transactions.success. Failures get the routing key, transactions.failure. It's real simple, really understandable. So our successful transaction handler binds to the queue and subscribes to transactions.success. The fraud specialists, they bind to the queue and they subscribe to transactions.failure. And you got the transaction logger, special thing, it binds to the queue and it subscribes to transactions.pound, and that's a wildcard. And you can imagine just how powerful being able to subscribe to a wildcard topic is. Cool. All right, so what winds up happening, you got transactions coming in onto a queue, Fraudomatic reads them off the queue, and they go into an exchange, the post-fraud exchange. Successful transactions get the routing key transactions.success. Failed transactions get the routing key transactions.failure. The debit processor gets its own queue that all these successful transactions get put onto. The fraud specialists get their own queue that all the fraudulent transactions get put onto. And the transaction logger gets yet another queue that all the transactions.whatever transactions get put onto. So let's actually do this, all right? So I go over here. This is our transaction logger. I'm just going to start it up. Over here, our fraud specialists, I'm going to start them up. Our successes, I'm going to start them up. Fraud-o-matic, pull the ripcord, start that guy up. And then let's create some transactions. So I'm going to pump about 7 transactions through. 1, 2, 3, come on, 4, 5, 6, 7. All right, let's go over to the fraud-o-matic and see what happened. Oh gosh, what's going on? Run. Going to bed. This only happens when I'm giving the talk. Okay, we gotta kill this. Stop. You are messing me up. Okay, let's try this again. So let's create some transactions, pump them through, make sure they're actually going. There we go. All right. 3, 4, 5, 6, 7. Let's see what happened. So we got 1 success, 2 success, 1 failure, 3 successes, 2 failures. I think that's a 4th failure. So we go over to the successes. I got 1, 2, 3 successes. Go over to failures. I got 1, 2, 3 failures. Go over to both. I got 6 log transactions. So what we've done is we've taken this queue broker, we've kind of moved these pipes all around, and we've created this whole service-oriented architecture in a presentation. That's actually kind of cool. So what are your options? You got things like RabbitMQ, you got ActiveMQ, IronIO if you're into the whole software as a service thing has IronMQ. You've got some sort of weird queue brokers like ZeroMQ, which is completely brokerless. It all uses UDP multicast. And you got things like Amazon Simple Queuing Service, which is a simple queuing service in the cloud. And it's, easy to use. So thank you very much. I got time for questions.
What did you make your presentation in? That was awesome.
Yeah.
This is the Go. This is a language called Go. This is the Go Present tool.
Cool.
And what you do is you've got this text file, and it processes it into these slides, and you can embed Go programs into it.
Cool. Because in a lot of ways, this is really similar to the IPython notebooks because they use ZeroMQ as their messaging system.
Yeah.
With cells with HTML and Markdown and Python cells in it. It's really similar, but having the service running was really cool.
Yeah. What I've got RabbitMQ running on the laptop, and these programs are just sending messages to the local RabbitMQ instance, and the other ones are pulling them off the local RabbitMQ instance.
No, it was a very cool presentation. I think you should have more selfies with fantasy.
I don't photograph well, so...
That's imposter syndrome.
Get it in there.
No, I'm just curious, so the fraud-o-matic, is it 5,000 or 3,000? Is that serve as a bottleneck? Do you get the advantage of the queue broker there, or?
You do. What you could pretty easily do, here we go, is if you needed to, you could scale these guys horizontally. So the fraud-o-matics are all reading off of this transaction firehose queue, and they're all publishing to the post-fraud exchange. Yeah. Thank you very much.